the next transformation we're going to look at out of section 2.5 are reflections. Now, I do want to remind everyone a point I made when we looked at vertical and horizontal shifts, that in general, for all the transformations, you can identify vertical or horizontal transformations by whether you see a transformation outside the argument of the function, which is vertical, or inside the argument of the function, which is horizontal. And reflections are no different. Right? A vertical reflection, which would reflect about the x-axis, you will see a negative sign outside the argument of the function, in this case, minus f of x. However, a horizontal reflection, or a reflection about the y-axis, you will see that negative symbol inside the argument of the function. So keep that inside-outside pattern in mind as we look at the later transformations in this chapter. With a vertical reflection, we will be changing the sign of the y-coordinates, essentially multiplying the y values by a negative. Conversely, the horizontal reflection, we will change the sign of the x-coordinates, or multiply them by a negative. Page 287 of your textbook introduces reflections, and the first reflection it will go review is the reflection about the x-axis, or a vertical reflection. One practical example of this type of reflection is if you take a picture on your phone and the picture is upside down, you need to rotate it 180 degrees. You can consider this an example of a vertical reflection. And so the graph of minus f of x is the graph of y equals f of x reflected about the x-axis. And so you'll see this visualization here with our quadratic function. So essentially what we do is we multiply the y values by a negative. So for example, minus 2, 4 becomes minus 2, minus 4. Right? And 2, 4, the x value stays the same, the 2 is the same, but 4 becomes minus 4. So this will reflect the graph around the x-axis, or a vertical reflection. Let's look at example 4 from the textbook. Use the graph of f of x equals the cube root of x to obtain the graph of g of x equals minus cube root of x. As we will do in all our transformations problems, we want to identify what transformations we have, what order we'll do them in, and of course what the algebraic manipulations will be. So here we have a vertical reflection. And what we want to do is change the sign of the y coordinates. You can also consider that the same as multiply by minus 1. So let's come up with the base points of our function, x and f of x. And this will be minus 8, minus 2, minus 1, 0, 0, 1, 1, and 8, 2. Again, this is the cube root function. So let's apply our transformation. Now, we're only changing the sign of the y coordinates. So the x values we can just copy. But the y values here, now I'm basically going to change the sign or multiply by minus 1. So this will become positive 2, positive 1. That'll stay 0. And this becomes minus 1 and minus 2. Looking at the graph in the textbook, you'll see here's our original function f of x, and it has been reflected about the x-axis. Right? This part of the curve here is now below the x-axis, and this part of the curve here that was below the x-axis is now above. And if we look at our coordinate points, you'll see 3 points. Right? There's minus 8, minus 2, 0, 0, and 8, minus 2. You'll see all those points are the same on the graph in the textbook. Now let's look at an example of a horizontal reflection, or a reflection about the y-axis. So if you have your graph y equals f of x, y equals f of minus x, will be the reflection about the y-axis, or again, a horizontal reflection. So let's look at example 5 here. Use the graph of f of x equals square root of x to obtain the graph of h of x equals square root of minus x. Looking at example 5, again, what we want to do is identify what transformations we have and what the algebraic manipulation will be. So now we have a horizontal reflection. Again, notice that minus sign is inside the argument of the function, unlike in example 4 when it was outside the argument of the function. So we have a horizontal reflection, and what's our algebraic manipulation? We're going to change the sign of the x coordinates. And again, you can think of that also as the same as multiply by minus 1. So again, we'll come up with the base points of our function. So this would be 0, 1, 4, 9, and 16. There's our 5 coordinate points. And then we'll just take the square root. And let's apply the transformation. So now we'll have x and h of x will be the y values. Now here we're only changing the x coordinates. So in this case, I can copy the y coordinates. And now we're just going to really multiply these values by minus 1. So of course 0 will stay 0. This will be minus 1, minus 4, minus 9, and minus 16. When we look at the graphs in the textbook, here's the original square root function, and they're only using the first 3 points instead of 5 like I showed you in our solution file. But here you can see it's been reflected about the y-axis, or a horizontal reflection, right? These x values of 1 and 4 have now become negative. And again, with our tabular method, we've identified those points, right? You can see the point 0, 0, minus 1, 1, and minus 4, 2. We identified those all algebraically first, and then we could graph the final function at the end.